Hi students, my name is Sakesh Shetty from XII Engineering College, Mangalore, and this is the continuation of the last previous uh, chapter. This is water's water. We can say that a zone of aeration is the zone of aeration. We are divided into two parts. Here, water held by hygroscopic matter. Here, water held by here in between the air voids, as I told, if the soil or rock in between air is filled, the water is held by hygroscopic or capillary action. Water is held by the capillary action. Water will move like this. So water is held by hygroscopic action. Hygroscopic hygroscopic action. Capillary rise. It will, and so we know that formula is uh, 2 through sigma cos theta into cos theta divided by capillary rise r into gamma, specific weight of water, the specific gravity of water. This we studied in the last chapter also. Here, this is one why I told the zone of aeration is the zone of saturation. The zone of aeration, the water is filled by hygroscopic action or capillary action. The water is filled. So essentially, where does water, as I told, water is held by hygroscopic action or capillary action and capillary action and groundwater. So water is held by water is held by gravitational action gravitational action water is held by gravitational action. Okay, this is water is held by gravitational action, and this water is held by hygroscopic action. Continuing this mm, expression for this capillary rise. So here I will draw one more line. Suppose this is capillary tube, which is basically narrow tube. This is center line. Diameter of the tube is given by 2r, uh, and so this is surface tension force is measured by force per unit length, and this angle theta. This is water surface. This is meniscus. This is the this is liquid, and this is in case water, this case with the specific weight gamma, and this theta is the angle of contact which was I mentioned there. To say, for if further simplified, this surface tension which is measured by force per unit length, generally it has the value of 0.074. This is grams per centimeter. Of course, it has to be multiplied acceleration due to gravity 9.89 specific weight of water, and this is 1 gram per cubic centimeter, and centimeter cube, again multiplied by this, multiplied by g. G is the gravitational acceleration, which is 9.81 meter per second square, and this is theta is approximately equal to 0 degree for water and clean glass. Same thing can be assumed water and soil also. Same can be assumed water and soil also. Can be assumed for water and soil also. So therefore, expression for capillary rise H, it reduces to 0.15 divided by R. Okay, so as we can see for this one, capillary rise H, which determines the height of the capillary zone, inversely proportional to size of the capillary pores, that is radius of the capillary force, that is basically here absorbed at more approximately force into equivalent circular shape, taking its radius. So that is H equivalent circular radius gets reduced, height of the capillary rise increases, and here it's mentioned that for different samples, that is the so the material grain size, material grain size, millimeter, capillary rise, capillary rise, capillary rise in centimeter, capillary rise as low as the 2.5 centimeter. We can say material grain size and capillary rise, material grain size and capillary rise. So fine gravel grain size is we can say that one 0.05 to 0.2, capillary rise is 2.5. 0.02, 2.5. Okay, and further as we go, next is coarse sand. Of course intermediate formation is there. So here we can say coarse sand, for which it is a 1 grain size is 1, that is 0.1 to 0.5 millimeter. It has a capillary rise of 13.5 centimeter, 13.5 centimeter, and then I'm sorry, I made a mistake here, and let me correct this one. This is grain size is 2 to 5, sorry, make 2 to 5. and coarse sand. Grain size is 0.5 to 1. 0.5 to, let me read it this again. So fine gravel is 2 to 5, and coarse grain is 2.5, and coarse sand, medium sand. Medium sand, it means zero point 0.2 to 0.5. You can say coarse capillary rise 24.6, and fine sand is zero point 0.1 to 0.2, capillary rise is 42.8. So next, silt, I can write it again, this one. Silt is 0.05 to 0.1, capital rise 105.5, and fine seal is 0.02, 0.05, 200, capital rise increases 200. This has been next source Lahman, study by Lahman source. Okay, now let me also represent here distribution of water in a coarse sand. Distribution of water in coarse sand. Distribution of water in coarse sand. Water distribution in coarse sand above the water table. Above the water table after drainage. So here, suppose this is the moisture. This is the soil moisture content as percentage. This is the height above water table in centimeter. Here let us say this is height of water table in centimeter. This is 20, and this is 40. This is can say, here we can see this one. This is 20, 40, 20, 40. So here this variation is it will something like this. So this is the, so this represents porosity, and here this represents capillarism, and above this represents intermediate zone. Intermediate zone. So in the capillary zone, just water table level moisture content is exactly equal to the porosity as we go above the water table. So moisture content goes on decreasing as we can see here. So when it is reaches intermediate zone, moisture contents only represent the hygroscopic water. So here we can see that this is the hydroscopic component. This is the moisture content helped by capillary action. This is a motor concentrated by hygroscopic water. So therefore, intermediate zone entirely entirely water is held by intermediate zone. Water is entirely held by hygroscopic water, and this is the capillary action. This is the hygroscopic. Water is held by in the intermediate zone. Water is held by hygroscopic action. This is the intermediate zone, and this is a capillary zone. This is the capillary zone. The water is held by capillary action. This one. This here hygroscopic and capillary action, and here only hygroscopic action. Intermediate water is held by hygroscopic action, and below the hygroscopic and capillary action. So we can see how it varies. So here just check the water table level just above the water table, almost all the pores filled with the moistures, soil moistures. As goes higher and higher, it is only those pores which continuous, they will be filled by water, and reach this intermediate zone. So only it is only this only this hygroscopic, which is the water helped by force of attraction between the spaces, void spaces, as well as the air, soil, as well as the soil, rock particles, and then the water. So this is how what zone of saturation water is held entirely by gravity, and that is for all the zone below the water table. And as we go above at the water table, so this water held by hygroscopic as well as capillary action, and reach the intermediate zone, number of pores which contains it's get continue only those continuous pores. They first of all the capillary action very small size, then through which capillary rise takes place with force of attraction between the soil or rock particles and the water due to surface tension force, and above that intermediate zone it's entirely by intermolecular attraction between soil moisture, air voids, as well as soil or rock particles. Thank you very much.